Magnets are cool. There are all kind of fun experiments you can do with them, but their usefulness can be rather limited. A magnet always attracts, but by using electromagnets that all changes and the applications become endless. Electromagnets are used in all kind of electric devices including loudspeakers, motors, generators. We use them in scrapyards to pick up heavy metals such as cars and move them around. They're used in relays, transformers, doorbells, buzzers, etc. etc. Okay, so now we know how important they are to us. What is an electromagnet and how can we build one? An electromagnet is a magnet in which a magnetic field is produced by an electric current. You just need a coil of wire with an iron core inside. Now you connect the wires to a voltage supply and a switch and you're done. The magnetic field will be perpendicular to the electric current and will disappear when the current is turned off. This is extremely useful as they can be turned on and off simply by controlling the supply of the electric current. The direction of the magnetic field can be found with the right-hand rule. If the fingers of the right hand are curled around the coil in the direction of the current flow, then the thumb points in the direction of the field inside the coil. How do we calculate this magnetic field? Surely we want it as strong as possible, so let's see what it depends on. The symbol for magnetic field strength is B with unit of Teslas. It is calculated as the permeability of free space times the current for one turn in the electromagnet. If you have n turns, then you multiply by what you call the turn density, which is the number of turns divided by the length of the electromagnet, resulting in such equation. The permittivity of free space is a constant with value 4 pi times 10 to the minus 7 newtons per amp squared. That is so small, right? So how do we even get a reasonable value for B when we're multiplying by a current which reaches values normally of not higher than 10 amps? By increasing the number of turns then. Also, if you add a ferromagnetic core like iron, it increases the magnetic field strength up to thousands times stronger than the coil alone. By looking at the formula, we can see that increasing the current will also result in a greater B. Hope you enjoyed this video and that you now have a general idea of electromagnets.